Rule number 4, powers of powers with many bases. This is what I mean by that. Here's an example. We have x to the power of 2, y to the power of 3, all in brackets, all raised to the power of 2. Okay, which means x to the power of 2, y to the power of 3 times itself. Okay, which gives us x to the power of 2 is x times x, y to the power of 3 is y times y, times itself again, times x times x times y times y times y. Now I'm going to, remember, these are all multiplying each other. Multiplication is associative, so I can remove the brackets, and multiplication is commutative, so the order doesn't matter. So what I'm going to do is I'm going to rewrite that with the brackets removed, all the x's beside each other. Notice there are 1, 2, 3, 4 x's multiplying each other, and all the y's multiplying each other, and there are 1, 2, 3, 4, 5, 6 y's multiplying each other. So we end up with x to the 4 times y to the 6. Now notice that x in brackets, x to the 2, y to the 3, close brackets, all to the power of 2 is the same as if that 2 came in and multiplied the 2 to give us x to the 2 times 2, and the 2 came in, distributed it in, multiplied the 3 exponent, giving us x to the 2 times 2 times y to the 3 times 2. It's like the 2 distributed to multiply each of these exponents. Okay, here's example 2. Let's see if that happens here as well. X to the 3, y to the 2, all to the power of 4. Okay, so we have x to the 3, y to the 2 times itself 4 times. All right, which is going to give us x times x times x times y 4 times over. All right, and then notice how many x's we have all together. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's times 1, 2, 3, 4, 5, 6, 7, 8 y's. Okay, so x to the 12 times y to the 8. Okay, and notice it's the same as just multiplying the 4 times 3 and the 4 times 2. All right, so x to the, in brackets, x to the 3, y to the 2, close brackets, all to the power of 4 is the same as, though the 4 came in and multiplied the 3, x to the 3 times 4, and multiplied the 2, y to the 2 times 4. Okay, and that's basically our rule. Okay, so rule number 4 is if you have powers of powers, and you have different bases, what's going to happen is that exponent on the outside is going to come in and multiply all of the exponents on the inside. All right, it's kind of like the distributive law for exponents. Now notice that can only happen if you have a single term on the inside. All right, if you have addition or subtraction on the inside, all bets are off. You're going to have to use binomial multiplication or trinomial multiplication or FOIL of some sort, distributive law of some sort. Okay, but you cannot use this rule if you have a binomial or a trinomial or any kind of nomial other than a monomial. Okay? All right, so the simple shortcut is the exponents, this p on the outside, the exponent on the outside of the bracket, is distributed to multiply all the exponents on the inside. Okay? So, here's an example. We have x to the 12, y to the 7. These guys have different bases. If they had the same base, you'd simplify inside the bracket. Okay, different bases. The 20 is going to come in, multiply the 12, multiply the 7, giving us x to the 12 times 20 times y to the 7 times 20, which is going to give us x to the 240 times y to the 140. Example 2. Here we have 3 to the 19 times 2 to the 16 in brackets, all to the power of 5. The 5 is going to come in, multiply the 19 and 16 exponents. So we have 3 to the power of 19 times 5 times 2 to the power of 16 times 5, which is going to give us 3 to the 95 times 2 to the 80. Okay, these are huge numbers. Do not try and work them out. All right, example number 3. Here we have 2 to the 3, x to the 8, y to the 4, all to the power of 4. The 4 is going to come in and multiply all these powers. All right, so we're going to get 2 to the 3 times 4 times x to the 8 times 4 times y to the 4 times 4, which will give us 2 to the 12, x to the 32, and y to the 16. And that is it for rule number 4. Have a good day.